Hello, and welcome to this last video in the quantitative chemistry topic about gas volumes. Please note this is for the chemistry triple science only and also higher tier. In order to calculate gas volumes, there's one very important piece of information that you need to know. 1 mole of any gas has a volume of 24 decimeters cubed at room temperature and pressure. Although hydrogen molecules are much lighter than, say, oxygen molecules, if we have 1 mole of hydrogen gas, it will have the same volume as 1 mole of oxygen gas. So in order to calculate the volume at room temperature and pressure of any gas, all we need to know is how many moles of that gas we had. The volume of the gas will equal the number of moles times by 24. If you want to have the volume in centimeters cubed, then you need to remember to convert decimeters cubed to centimeters cubed by multiplying by 1,000. Right, let's look at some examples. If we have 2 moles of carbon dioxide gas and we want to know what volume is taken up by that gas, we write out the equation as volume equals moles times by 24. Remember that this is dm cubed. So the moles is 2, we times that by 24, and we get 48 dm cubed. Of course, if you need to convert it into centimeters cubed, then you need to times it by 1,000, and so you get 48,000 centimeters cubed. To calculate the volume of half a mole of nitrogen gas, well, all we need to know is how many moles we have. So the volume equals the number of moles, which is 0.5 for a half, times by 24. That gives us 12 dm cubed. And to calculate how much space 0.1 moles of fluorine gas takes up, well then the volume is going to equal 0.1 for the moles times by 24. That gives us 2.4 dm cubed. And of course, to convert it into centimeters cubed, that will equal 2,400 centimeters cubed, or 2,400 centimeters cubed. So that's the simplest way of using this gas equation triangle. But it's possible in the exam that you might also be asked to calculate the volume of a gas from its mass and relative formula mass. Of course, we always get the relative formula mass from the periodic table. So a question might ask us to calculate the volume of a gas simply from its mass. So this time the first step is to figure out how many moles we have so that we can use the gas equation triangle. And in order to find the number of moles, we need to use this equation triangle using mass divided by relative formula mass. So to find the volume of 22 grams of carbon dioxide gas, the first thing we do is to find the moles, which equals the mass divided by the relative formula mass. The mass is 22 from the question, and the relative formula mass of carbon dioxide is 44. That gives us 0.5 moles of carbon dioxide gas. Well, now we can use the second equation triangle. Volume equals moles times 24. So we have 0.5 moles times by 24 equals 12 decimeters cubed. If you're up for it, have a go at doing the next two examples before I write out the answer. So to figure out the volume of 2.8 grams of nitrogen gas, the first step is to find the moles, which will equal the mass, which is 2.8, divided by the relative formula mass, which for nitrogen gas is 28, because nitrogen has an MR of 28. Remembering that nitrogen is a molecule containing 2 atoms of nitrogen joined together. So this gives us a moles of 0.1, and now to find the volume, we do moles times by. We do the moles, which is 0.1, times by 24, and that gives us 2.4 dm cubed of nitrogen. And finally, let's figure out the volume of 1.9 grams of fluorine gas. Remember that fluorine is one of those gases which is a molecule of 2 atoms joined together as well. So the first step is moles equals the mass, which is 1.9, divided by the MR, which for fluorine is 2 times 19, which is 38. That gives us a moles of 0.05. We can then put that into the volume equation, so the volume equals the moles, which is 0.05, times by 24, and that gives us a volume of 1.2 decimeters cubed. Remember, as I've said before, it's really important to always write down the units of your calculation. Especially important when we're calculating volumes, as if you leave it out, it won't be clear whether you mean decimeters cubed or centimeters cubed, and you could lose valuable marks. This question makes the calculation a little bit harder, and it's starting to lead towards that idea of reacting masses that we had before, where we have to look at a balanced equation and figure out how much of one thing we have based on some information about another thing. So in this case, the question is asking us what volume of carbon dioxide gas is produced when an excess of hydrochloric acid is added to 0.05 moles of calcium carbonate. So, in order to find the volume of carbon dioxide gas, the first thing we need to do is use the moles ratio to find out the moles of carbon dioxide that we have. So, according to the equation, you can see that the moles ratio is 1 to 1. This means that if we had 0.05 moles of calcium carbonate, we also have 0.05 moles of carbon dioxide. So now we can go back to this equation and calculate the volume of carbon dioxide from there. Volume equals the moles, which is 0.05, times by 24, and that gives us 1.2 decimeters cubed. And of course, it may be that the question is asking you for a volume in centimeters cubed, and if that's the case, then you need to times it by 1,000 and get 1,200 centimeters cubed. And finally, this is the hardest type of question you might be asked. You're given an equation and you're asked to find the volume of one substance from the volume of another substance. In this case, we're trying to find out what volume of carbon dioxide gas will be produced when an excess of propane, which is this, is burned in 1.2 decimeters cubed of oxygen. Okay, so that's what we know so far. As we know from before, we need the moles of the carbon dioxide to know the volume. So we need to work out the moles, and we do this by first finding the moles of oxygen. So step 1, the moles of oxygen will be its volume divided by 24 from this triangle. So the volume was given to us as 1.2, and we divide it by 24 to give us 0.05 moles of oxygen. Now we need to use the moles ratio to find out how many moles of carbon dioxide we had. In this equation, we have 5 moles of oxygen to 3 moles of carbon dioxide. This means if we have 0.05 moles of oxygen, we must have 0.03 moles of carbon dioxide. Okay, so now we have the information we need to calculate the volume of carbon dioxide. So step 3, volume equals the moles times by 24. The moles is 0.03 as we just worked out, times that by 24, and we get 0.72 decimeters cubed. If you wanted this in centimeters cubed, of course, you times by 1,000, and you get 720 centimeters cubed. And that's all you need to know about gas volumes. Here is a summary of the equations we used today. These ones here at the bottom are the main equations we need for gas volumes. The only difference between the two is that in the blue one we're looking at decimeters cubed, and we can use the red one to calculate volumes in centimeters cubed. Of course, with the more complicated calculations, you might also need to bring back the moles triangle using mass and relative formula mass. I hope you found this video useful, and I hope you now feel a little bit more confident doing calculations in chemistry.